All right, Algebra, we are checking out 6.7 notes today. Excuse me. So we are kind of jumping ahead, and then we're going to come back and revisit 6.4 and check out 6.5 and 6.6. But we are going to go ahead and introduce this concept so you have a little more time to practice it, and you can kind of see the end game. So we are graphing linear inequalities today. And the first thing to know is that a solution of an inequality in two variables looks differently than the inequalities we've been looking at because those have only had one variable so far. So anytime we have two variables, our solution is always going to look like an ordered pair. So we are going to have an XY pair that produces a true statement when the values of x and y are substituted into the inequality. So remember, we are looking for a true statement, and I'm substituting in the whole pair. So here's what that looks like on your first couple problems. Tell whether the ordered pair is a solution of the inequality. We did this exact same skill early on in the year in chapters 1 and 2, or maybe 3, with equations. We're doing the same thing with an inequality. So here's my inequality. 4x minus 7y is greater than 28. And now I'm going to take this ordered pair and substitute it into my equation to see if this makes a true statement. So -2, I'm going to substitute in for x. 4, I'm going to substitute in for y. And then I'm going to simplify and see what I get. 4 times -2 is -8. -7 times 4 is minus 28. So as I subtract to further simplify, -8 minus 28 is -36. And I cannot simplify anymore, so I'm down to a statement. -36 is greater than 28. That, of course, is not true, so the answer is no. This point, this ordered pair, is not a solution of this inequality. Let's check out number 2. 3/4 x minus 1/3 y is less than 6. I want to know if -8, 12 is a solution. So I'm going to substitute -8 in for x. And I'm going to substitute 12 in for y. And see what I get. So I'm going to simplify first by multiplying, then subtracting according to the order of operations. So as I multiply 3/4 times -8, I know that 4 and -8 will cross cancel to -2. So 3 times -2 is -6. And as I multiply here, I know that 3 and 12 will cross cancel. So -1 times a +4 gives me a -4. As I subtract to further simplify, I have -10 is less than 6. That, of course, is true. -10 is less than 6. So the answer to this one is yes. -8, 12 is a solution to this inequality. So kind of a review skill, just a new look at using inequalities. Now here is the next thing that you need to know about graphing inequalities. Obviously, with two variables, it's going to look very different than graphing inequalities in one variable. So in a coordinate plane, the graph of an inequality in two variables is the set of points. So this is going to be lots and lots and lots and lots of points that represent all solutions of the inequality. So we are going to have what is called a boundary line. And this boundary line of our linear inequality divides the coordinate plane into two half planes, because this boundary line is going to extend forever in both directions. So it's going to take our whole plane and divide it into half planes. Only one half plane contains the points that represent the solutions of the inequality. So just like when we were graphing inequalities on a number line and we would shade our solution set, we are going to shade on our coordinate plane to show the solution of the inequality. I know this sounds confusing, but we're going to run through the steps and then I'm going to show you an example. And as you start to see the examples, it will start to make a lot more sense. So remember, this is looking different because we are graphing a linear inequality in two variables. That's why a number line is no longer sufficient. We're in 2 dimensions now. So first we're going to graph the boundary line. So we're going to use all of those skills we've learned in chapters 3, 4, and 5 about graphing lines, and we're going to graph the boundary line. Then I'm going to apply that same concept as we used on a number line. We said if I had an inequality such as x is less than 3, I would use an open circle and shade everything to the left. That open circle told you that I used the less than symbol. Well, in this graph, we're going to use a dashed line if we use a less than or greater than symbol, and we'll use a solid line as our boundary line if we have less than or equal to or greater than or equal to. So it's similar to our open circle on a number line versus a closed circle on the number line. So once we have graphed that line, our next step is to test a point that's not on that boundary line. And we're going to check whether the ordered pair is a solution of the inequality. So I'm going to pick a point not on the line and I'm going to substitute it into the inequality and decide if it's a solution or not. And remember, that's what we just did on these examples. So we're going to be using this skill here to test a point. If that point is a solution, then I'm going to shade that half plane containing that point. If the point I test is not a solution, then I'm going to shade the other half plane. And again, this will start to make a lot of sense as we look at an example. So let's check it out. On your homework, you'll have a question like this. You'll be given an inequality in 2 variables, and you're going to be asked to graph that inequality. So using our hint, we are going to solve this inequality for y and then graph, because essentially we are getting into y equals mx plus b form. We want our inequality to mirror that slope-intercept form. So that's why I'm going to solve for y. So to do that, I'm going to give myself a little more space and rewrite this equation down here at the bottom. So I have 2y minus 4x is greater than negative 10. So my first step to getting y by itself is to add 4x to both sides. So over here, I'm left with 2y. Negative 4x and positive 4x are additive inverse, so they cancel to 0. And here, these are not like terms, so I'm going to put this in mx plus b form. Now I want to get y by itself, so I need to undo the times 2. I can undo multiplying by 2 by dividing by 2. So my 2's cancel, and I'm left with y on this side. And over here, I have to do 4x divided by 2, which is 2x. And I have to do minus 10 divided by 2, which is minus 5. So this is my equation of the boundary line. So I'm going to graph this line just like I do with all of my others. I'm going to start at my y-intercept, which is negative 5. And then I'm going to use my slope to find the remaining points on this line. My slope is 2, so from my y-intercept, I'm going to rise 2, run 1, rise 2, run 1, rise 2, run 1. Now before I connect these points in a line, I need to look at my symbol to know whether I'm going to use a dashed line or a solid line. Since I have a greater than symbol, I'm going to use a dashed line and attempt to draw it fairly straight. Okay, now I have my boundary line drawn. So I need to choose a point, a test point that I can check. So I'm going to pick the point 1, 1 because it will be an easy point for me to test. So this is going to be my test point. And I'm going to test to see if this point is a solution of this inequality. So I'm going to substitute 1 in for x and 1 in for y. As I do that, I need to simplify to see if this is a true statement. 2 times 1 is 2, and 2 minus 5 is negative 3. So as I simplify this inequality, I'm saying that 1 is greater than negative 3. That is a true statement. So that means that this point is a part of my solution. So what that tells me is that I need to shade this half of the coordinate plane because this is my solution set. Because the test point was a solution, so I shade this area. All right, now that you've seen it once, let's try it again. Take it from the top. If we are solving number 4, I know that I have an inequality in 2 variables, so I'm going to solve this for y and then graph it. So before I even begin here, instead of distributing this 3, I'm going to go ahead and divide both sides of this inequality by 3 because that will just save me a step. So I'm going to rewrite this inequality down here where I have a little more room. So we have 3 times the quantity, x minus y, is greater than or equal to 12. So my first step is going to be dividing by 3. So I now have x minus y is greater than or equal to 4. And now I'm going to go ahead and subtract x from each side. And there are other steps you could use to do this as well, but I'm going to go ahead and choose to do this because it lets us practice the skill now of dividing by -1. And that will remind us and help us build the habit of anytime we divide by a negative number, we have to flip our inequality symbol. So -y divided by -1 is positive y, and I'm going to reverse my symbol so it's less than or equal to. X divided by 1 is x, negative divided by negative cancels, and I have 4 divided by -1, so this becomes -4. So my inequality is y is less than or equal to x minus 4. So this is the line that I'm going to graph. So to graph this, I'm going to start at my y-intercept, which is -4. I'm going to put that point on my graph. Now I'm going to use my slope, which is 1, and I'm going to find my other points. So from my y-intercept, I'm going to rise 1, run 1, rise 1, run 1, rise 1, run 1. And now before I connect these points into a line, I need to check my symbol. It's less than or equal to, so I'm going to use a solid line this time. And that indicates that the line itself is part of my solution set. Now I'm ready for my test point, and I again am going to pick the point 1, 1 because it's so easy to substitute in. So as I substitute 1 in for y, let me rewrite my inequality up here for us. I'm going to substitute 1 in for y and 1 in for x. 1 minus 4 is -3. 1 is not less than or equal to -3. So this point is not a part of my solution set. So what that means is that whichever half plane this point exists in is not my solution. So I shade